Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem, path with minimum effort. So the problem is saying is we'll be given heights, okay, a 2D matrix basically, and wherein each cell represents the height, okay, represents the height of the cell. You are situated in the top left cell and you hope to travel to the bottom right cell. Okay, it's a zero-based indexing. You can move up, down, left, or right, and you wish to find the root with the minimum effort. A root's effort is a maximum absolute difference in heights between two consecutive cells of the root. So let's see through the example what the problem is trying to say. Okay, so we'll be given a 2D matrix, right, which is called heights, and each cell represents the height of the cell and will be situated in this position, or the hiker is situated in the top left position, and we want to reach to the bottom right position, okay, with minimum efforts, okay, and the hiker can move either in right, bottom, left, or top, okay, in these directions, okay. So in this way, there can be how many paths? For example, let's see, one path can be one, this, right, this particular path, that is 1, 2, 2, 2, and 5. One can be this particular path, right, 1, 2, 3, then 3 to 5, then this, 5 to 3, then this, 3 to 5, right? Another path can be 1 to 3, then 3 to 8, then 8 to 3, and 3 to 5, right? There can be various paths again, 1, right? 1 to 3, then 3 to 8, then again 8 to 2, and 2 to 5, okay. So what you have to do is, right now, what the problem is saying is, initially, for example, if we consider this particular path, right? So initially, the distance it is going to be 0, right? So when we move from this cell to this cell, right? So what is the distance it is going to be required? It is going to be required, right? The difference between these two cells, right? So 2 minus 1, it is 1. Okay. And also what we're going to do is, we are going to compare. We are going to compare with the previous distance, okay? And what it is saying, maximum absolute difference in heights between two consecutive cells, okay, between two consecutive cells. Okay, so we are going to consider the maximum. We are going to compare with the previous height with the current height. Okay, so we are going to take maximum. So 1, 0, maximum is 1. To reach from here to here, it is going to take what? 0, right? 0. But we are going to compare with the previous one. So it is going to be 1. Similarly, it is 0. Compared with previous one, it is going to be 1. Similarly, it is 3. If we compare with the previous one, maximum is this. So it is going to be this, right? Similarly, here, again, if we start for this path, it is going to be 0, the previous one. If we compare, right, what is the difference? It is going to be 2, right? If we compare, maximum is still going to be 2, right? Here, 2, no change, previous is same. 2, no change, previous is same. 2, no change, previous is same, right? 2. Here again we start. What is the difference? It is 2. What is the difference? It is 5. If we compare with the previous one, it is still going to be, maximum is 5. So it is going to be 5. Here 5 again. The previous one is same, so it remains unchanged. Here it is 2, but the previous one is what? 5. So we are going to consider 5. Okay, so here it takes 5. Similarly, again 2 here, 5, we are going to consider 5 because the previous one is lesser. Then it is 6 here. So we are going to consider 6 because the previous one is lesser, right? 3, the previous one is greater than, that is why you're going to consider 6. So now we are going to check out of all these, which is the minimum efforts, right? Minimum efforts is 2, this particular path. Okay, so we're going to return this 2. If you see here, 2, right? So this is the way, this is what is expected. Okay, now how are we going to solve this problem? Okay, how are we going to solve this problem? So what we have been asked is, okay, we have been asked to find the path with minimum effort. So whenever there is a path being asked, right, in a problem, and for example, it is, if it is shortest or minimum, so what algorithm comes into mind? The algorithm which comes into mind is Dijkstra's algorithm. Okay, so how are we going to solve the Dijkstra's algorithm? So we are going to take a priority queue, okay, a minimum priority queue, and we are going to take a distance 2D matrix as well, okay, initialized with infinity, okay. And now what we are going to take in this priority queue? We are going to take the distance, right, and to reach a particular cell, right, and the location of the cell, right? So we're going to start with this one, right, top left. So initially the distance it is going to be 0, right? And what is the cell position? 0, 0, right? And again, since we're starting, right, with this position, we are going to initialize with 0. Okay. Now let's make, what are the possible moves if we consider this right? So what it is going to be? So first we are going to take, okay, now what we're going to take? We're going to take maximum, right? Maximum of first, right? 2 minus 1. We're going to reach, if you have to go, right? So we are going to take the difference of heights, right? 2 minus 1. And the previous distance. What is the previous distance? So first what we're going to do, we're going to pop this out first. Okay, we're going to pop this out first and we'll check whether this is a valid position. Can we move? If it is a valid position, yes. And what we're going to do, we are going to compare, right, the heights, as I said earlier, right, as I explained earlier. So 2 minus 1 and the previous, what is the distance? It is 0, right? It is 0. So the maximum is 1. Maximum is 1. Now we are going to check in this position, right? What is the position of this particular cell? It is 0, 1. So we are going to check with this. So we have got distance of 1, which is lesser. So we are going to consider this, right? We're going to consider this distance 1. And also we're going to push in the priority queue 1, comma, the position of the cell, 0, comma 1, right? Position of the cell. Okay. Similarly, what we're going to do, we are also going to consider this one, right? We are also going to consider this one, right? So what it is, so it is 3, right? 3, we are going to 3. So what the formula is going to be? 3 minus 1. We are coming from 1, right? 3 minus 1 and the previous distance. The previous distance was 0, right? The 0, right? So what you're going to do? We are going to, what the height will be? The maximum will be 2, right? And again, we are going to compare with this one. Yes, this is lesser. So we are going to update this 2, right? And we are also going to push in the priority queue. 2, comma, this position. What is the position? 1, comma 0, right? 1, comma 0. Okay. Now, what we're going to do? We are done with like processing all the neighboring, right, nodes, all the neighboring nodes of 1, right? So now what we're going to do? We are going to check whether this particle is empty or not. It is not empty, and we are going to pop out the minimum one. So this is the minimum, right? 1, comma 0, comma 1 is the minimum. Okay. Now from this, right, we are at this position. So we are going to check which are the possible paths. So one possible path is this, right? One possible path is this. So what is the difference? 2 minus 2. We are going to take maximum, right? 2 minus 2, comma, what is the previous one? It is 1, right? It is 1. Okay. The previous one is 1. So by 2 minus 2, we are going to this 2 minus this 2, right? 2 minus 2 is 0. And what is the previous one we have to consider? The previous one is 1. So what is the max? It is 1, right? It is 1. Maximum is 1. So we are going to check now for this particular position, which is lesser, 1 or infinite. 1 is lesser, so we are going to update this, and we are also going to push this into this particular priority queue, right? What is the position of this? The position of this is 0, comma 2. Okay, the position of this is 0, comma 2. Okay. Now again we are going to check for this particular position. Okay, so what is the maximum? Maximum is 8, for example, 8 minus 2, right? The difference and absolute difference and the previous one, right? What the pop distance was 1, right? So the maximum is 6. 6, comma 1. So it is 6, right? So we're going to check for this particular position, what is the, which is lesser, infinity or 6? Definitely 6 is lesser. We're going to update this, and we are also going to put the 6 here. And what is the position? 1, comma 1. 1, comma 1. Okay. So if you check, right? If you check again, we can go to previous one also, but this is processed, right? It is going to return the same. So we won't go here. Now we are done processing with this, right? So once we are done, we are going to check. We are going to check the priority if it is empty. Again, we are going to pop out the minimum. What is the minimum one? 1, comma 0, comma 2. So this is the minimum one, right? So this way, we are going to keep on moving. We are going to keep on adding the elements in the priority queue. Okay. And then once we pop out and we find that, okay, we have got the minimum, whichever we popped out, right? And we found out that this is the destination. Then we're going to stop there and we're going to return the. Okay, I hope you got the intuition. Now we'll go to the code. Before going to the code, I request you to subscribe to my channel. Thank you so much. Now let's implement. First, I'm going to implement the Java code, then followed by C++. Okay, so what we're going to do is we are going to take a priority queue, right? A priority queue, a minimum priority queue, basically, right? So we're going to have an integer array pq equal to new priority queue. Okay, and we want to set this as a minimum, right? Minimum priority queue. So what we need to do is a comma b, right? So what it is going to be, we're going to compare the distance, right? So we are going to have this integer array, right? And what is integer array? It is basically this, right? Integer array. One is the distance and the rest two are the position, right? Coordinates basically. So we have to set this priority, minimum priority based on what? Based on the distance, right? Based on the distance. Okay. And we have to have minimum distance. So what we're going to do, we're going to compare the integer dot compare. What we're going to compare the distance, right? Between the two elements or nodes, a comma 0 and b comma 0. So we have set the priority queue, minimum priority queue, right? What else we're going to have? We're going to have a distance matrix equal to new int. The size will be same, rows, columns, right? And we're going to initialize this distance with infinity, right? The distance, what is going to be arrays dot fill, b comma integer dot maximum as an infinity. Then as we are going to start with the top left, right? So we are going to initialize this 0 with 0, right? Also, we are going to add in the priority queue, the top left position, right? So what it is going to be new in 0, the distance, and the coordinates 0, comma 0, right? This is going to be, and then we're going to run a while loop, right? pq dot is empty. So what it is going to be? Now we are going to pop out this the first one, right? PQ dot pole. We are going to have, for example, D, the distance, right? So cell of 0, and we are also going to capture the coordinates, cell of 1, right? Y equal to cell of 2. Okay. Now what we're going to do, we are also going to have, we have to go in 4 directions, right? So let's have the corresponding array, right? 1, -1, 0, and 0. Okay. And dy equal to, so if we make move 1, right? In the x, that is we're going down, right? Bottom. So y is going to remain unchanged. -1, if you're going top, it is going to be unchanged. If you're going to the right, y is going to be 1 and x is going to be 0. Similarly, there is some, yeah, -1 if you want to go to the left. Okay. So this, so now what we're going to do, we have popped this out. And now what we're going to do, we want to move to the 4 directions, right? In I equal to 0, I less than 4 plus I. Okay. Also, before that, we're going to check, right? If x equal, if it is a bottom right, then we have to return the answer, basically. Right? We're going to return the answer. So bottom right, rows -1, right? And then y equal to columns -1. So what we're going to do, we're going to return the D answer. Okay. Okay. Now let's move ahead if it is not the bottom right. Okay. So what we're going to do, int nx equal to, right? What we're going to do, the current cell plus dx of I is going to give us a position, right? Either of one, top, left, bottom, or right, right? Y plus dy of I. Okay. So we're going to check if it is a valid position, if it is not going uh, below or above or out of the matrix, basically, right? So you have to check it should be greater than equal to 0 and it should be less than rows, right? And dy should be greater than equal to 0 and dy should be less than equal to false, right? Okay. If it is the case, then what we're going to do, we're going to calculate the, for example, the difference, right? NDF, for example, NDF equal to, what we're going to do, we're going to math.max. Okay. Math.absolute of, take the absolute. What it is going to be, heights of nx and ny, right? What is nx and ny? For example, this, right? If you want to go to this position from this position, right? Or for example, from this position to this position, right? So nx and ny is this. Okay. Okay. Minus heights of x and y, right? We're going to take the maximum. And what it is going to be? The previous one, D. We are going to compare the previous distance, right? That's maybe we can call it PD, right? Previous distance, right? PD. Okay. We're going to compare, right? For example, what we did here, right? When we're going from here to here, initially it was 0, right? 0. So what we did, 1, 2 minus 1, right? It gave us 1. So we consider the maximum, right? So that's what we are doing here, maximum NDF. Now we're going to check if NDF is less than distance of NX, NY, right? So if we are checking here, earlier it was infinity here, right? So we are checking if it is lesser, if this is lesser, if NF is lesser, this is lesser than the infinity, then update that, right? Distance of NX, NY equal to NDF, right? Now also if it is, we are also going to insert in the priority queue, PQ dot add, right? New in what is going to be NDF is the distance and the position NX and NY, right? So this is it. And if we see, if we reach the destination, we are returning the answer, right? If we don't reach, right? If we don't reach, simply want to return -1. Let's compile and run this. There is some dx. Okay, sorry, it should have been nx here. NX here. Oh, again, we have some error. This error now. Columns. Should be columns. So see the errors. Let's compile now. Okay, it's submitted. The solution seems to be accepted. Thanks for watching. I hope you got the solution. Please subscribe to my channel. Now let's quickly see the C++ code as well. Okay, so here is the C++ code. Okay, so what we're doing is here, right? Here what we're taking we are taking the distance array, right? We have distance matrix, okay, and then we are having this the array for moving the 4 directions. We are what we're doing here is we also took the priority queue, right? Here we are comparing the minimum priority queue, right? We want, right? Here we are comparing, okay, okay. So priority queue, okay. So here what we're doing is, anyways, okay, here we have the minimum priority queue, and then what we're doing here is we are pushing the first position 0, 0, and then again we are moving here in the while loop, and we are checking. We popped out the first element, the first okay, the node. We took the difference R and C. If we are checking if it is the destination or the bottom right, we return the difference, okay, the height difference. If it is not, we'll check whether we can move in all the 4 directions, right? So here we are having the new position, updated position. We're checking whether it is a valid position. If it is, we are taking the absolute difference, the maximum, and then we are comparing with the position, the distance. If it is lesser, we are updating that particular position in the distance matrix, and also we are pushing the priority queue. Okay, we are pushing the priority queue. Okay, so this is the code. I hope you have got the code. Please subscribe to my channel. Thanks for watching. Have a happy and then a great day. Thank you so much.